Today we're going to solve a linear system of equations using substitution. The four steps that we have are the four steps that you would use to solve any system of equations using substitution. In this case, we're going to rearrange the equation using inverse operations so that y equals something or x equals something. When we get that value, we're going to substitute what we get for that into the other equation. That should eliminate a variable where we're going to, step 3, solve that equation. And finally, once we get the value of that variable, we're going to substitute it back into one of the originals to find the other variable. An example we did in class is shown by the slide here. We used this and solved it by graphing, and we also solved it using substitution. So to review, we have both y's as separate, so we're going to take the value and plug it into the second equation. I'm then going to rewrite the equation, but instead of writing y, I wrote 3x minus 12. I'm then going to solve it like I would any other equation, inverse operations to combine like terms, and once that happens, I should get a value for x. X equals 3, and so the ordered pair where those lines intersect is 3 something. So we take the 3, plug it into the original. 3 times 3 is 9, minus 12 gives us y equaling negative 3. The ordered pair for the solution is 3, negative 3. In the next example, you'll notice that instead of it saying y equals, it says x equals. And so to show you that solution, we're going to simply take the value for x, plug it in for the other equation, and now have the equation with just the y value in it. We're going to distribute the 2 to both the 3y and the 11. Combine like terms. Negative 6 minus 1 is negative 7. Negative 7y equals, that's negative 21, I apologize. So y equals positive 3. So our ordered pair up top here, the y coordinate is positive 3. I then substitute it into the second equation, making it easier because it's a straight calculation with order of operations. Negative 3 times 3 is negative 9 plus 11, x equals positive 2. And so my answer for the point of intersection is 2, 3. In the next example, I'd like you to try to solve this before I show you the solution. So hit pause and try to substitute x minus 6 into the value of y to find out the two values of x and y. Hit pause and do that now. After you completed the system, you should have done the following. Substitute x minus 6 in for the y. Distribute the 3. Combine like terms. Inverse operations. 5x equals 5 behind that window there, and therefore x equals 1. When we substitute the 1 in, I chose the second equation because it's an easy calculation, 1 minus 6, y equals negative 5. Hopefully you got that answer. Moving on to the next example, notice it in this system here, there's no x equals or y equals. And so the key to substitution is we have to pick a variable that makes it easy for us to solve. In this case, I see coefficients of 2 and negative 3 and negative 2, and that would require me to divide. The easiest variable to solve for would be this x right here. And to do that, first thing I would do would be to rewrite the equation. And to rewrite it, I know I'm going to be solving for the x variable. There's no division involved, simply adding 2y to both sides gives me x equaling 2y minus 1. Now I have x by itself, which was my goal, and so I'm going to take that 2y minus 1 and substitute it in for this x. Don't forget the 2 in front of the x. Distribute the 2. Rewrite the rest of the equation. Combine like terms. Use your inverse operations and find that y equals 6. My y coordinate is 6, and now I'm going to substitute that 6 in for the first equation. X minus 2 times 6 equals -1. If I add 12 to both sides, I should find that x equals 11. So just to review again, if you do not have x or y by itself, the first step is to rearrange like in that last example. Once you have x or y by itself, we're going to take that value on the other side. So if it was y equals whatever's over on this side here, substitute that value in for the equation, solve the equation, and then from there use that value to find the other variable. I hope this helps you finding the solutions to systems of equation by substitution.